All right, welcome back. So we're going to talk a little bit more about standard deviation and walk through problems with you. And the rest of chapter 3.2, I will there's like two parts of it. Stop to the end of this part. Okay. So let's go ahead and share the screen. All right. So let's see here. I want to talk to you first about some other attributes of standard deviation. So this just measures the spread. One of the things I like to ask are what kinds of numbers are things. So what I mean by that is, you remember the formula. So sigma or S, right? X minus mu squared sum, excuse me, X. This was sum X minus X bar to the samples, population mean, sample mean. Okay? Population standard deviation, this was sigma. Sample standard deviation, S squared, I, one, squared. And one of the questions I'll have is, can sigma or S be a negative? Is it possible to have a negative number? Well, look at the form. We're squaring some things, and we're always positive. We're adding up a whole bunch of positive things, and then we're going to take it square root. So, no, it's never going to be. So, no. Can standard deviation ever be zero? Well, what if we had a really, really boring data set? Right? Like, on list about it. I think if I look at, say, all of the people in my recount class this fall, they're all able-bodied. Well, I should say it this way. They all have all their fingers on each hand. So it's a boring data set. Everybody has 5 fingers. What's the average? Average is 5, right? And if I take each of these values and I subtract from 5 from it, right? We got 5 minus 5, 5 minus 5, 5 minus 5. We're going to get a lot of this. They're all 0. So when I square this and then add up all of the zeros, right? We're going to get zeros in here. They're all going to be 0. So yes, standard deviation can be 0, but it's not the usual kind of data set you're going to see. Most people are not interested in doing statistics on relatively healthy people. Okay. How many fingers do you have? Each hand. Most people are going to answer that. Not everybody. But yeah, you can have a really boring data set. Had a weird tomato crop, counted how many tomatoes came off of each plant. They all happened to yield 20 tomatoes. And it's like Twilight Zone-ish, but it happened. So standard deviation for this, 0. Yes, that can happen. Can standard deviation or sample standard deviation be positive? Yeah, all the examples we've done so far. So if I ask you, like, what kind of number can standard deviation be? So here's my any real number. I think that's all the different numbers that we have. Any positive? Positive. I shouldn't say it that way. I should say non-negative. Right? 0 is not exactly positive, but it isn't negative. So any non-negative. Okay. I have to fill out the, we're going to do multiple choice here. We need a couple more answers though. About any number between 0 or -1 and positive. That one's not good. Right? It can't be negative. But the number between 0 and 1. Well, this doesn't quite work because our first standard deviation, right? For example, we got 3.6. That's bigger than 1, so that's not true. And then I always put like 1 or 2 problems in here to kind of answers that just to fill it out. One of the ones I used to use, I still use it. A complex number, or none of the above. Say 2 things. 1, in your book, up to chapter 3, have you seen an imaginary number? Have you seen a number that looks like 3 minus 2 are imaginary numbers? The square root of -1 to be plus or minus I. And whether you've read your book or not, it's like, no, I have not seen this. Okay, statistics, we don't really work with imaginary numbers or complex numbers. So this is never the answer. Never the answer for complex numbers, right? We do not do statistics on complex numbers at the 100th level, right? It's just not happening. So I throw that on there, and occasionally I get a student who panics and like says, yes, complex numbers. Like, did we even talk about these? Never. We never talked about it. So no, it never is not the answer. Now, here's one that's a little bit of a special case, none of the above. So when you take your little educational psychology class, one of the things they talk about is multiple choice tests, like how to screw with your students. They always suggest putting a none of the above as an option on a multiple choice test because a lot of students will panic and say, all of you. And the thing is like if you never back this up, if this never is an option, then the smarter students will know never to pick it. But so it has to. You have to follow. You have to have a threat of none of the above. So the answer could be none of the above. But make sure it's none of the above. As soon as it's either all the numbers or it can't be any of the numbers. Like that's pretty much what your choices are. So it's either all the numbers or it isn't enough. That's what I'm going to say. In this case, that's not the answer, right? Standard deviation is a number that we can calculate. But be aware that none of the above could happen. It's not a common answer, but it's something that can happen. All right. Range. Can range be positive? Yeah, that's the first one we did too, right? Got a range, it's a positive number, we're good. Does it have to be between -1 and no, the first range we did have a range 30. That's definitely not between -1 and positive. Much bigger. Can the range be 0? Well, what if we had the same situation here, right? We're just counting fingers. Well, the biggest number is 5. The smallest number was also 5. So yeah, for the same reason that standard deviation could be 0, range could be 0. There's no variation. Can range be negative? Well, what if you were taking temperatures in and out? Could the range be negative? So what if we have the two extreme values, right? It's -8 and -30. What I'm going to ask you is, would you rather be $8 in debt, $30 in debt? Almost all of you are going to look at that and say, I would rather be $8 in debt than $30 in debt. -8 is a bigger number than -30. Okay? It's confusing because the magnitude of those numbers, right? 30 is a bigger magnitude than 8, but -8 is a bigger number than -3. Right? There's 0, it's -8, it's -30, it's 10. 10 is a bigger, it's further to the right, it's further to the right from these two values. -8 is further to the right than -8 is a bigger number. 30, even though if you take the magnitude, trigger flashbacks for people who know absolute values, that the magnitude of 30 is bigger than the magnitude of 8. If you get confused, -8 is larger than. So if we're going to go ahead and subtract, right? Biggest number minus smallest number. Max minus min, we're going to take -8 minus -30. What happens when we get the minus minus? -8 plus 30, which is equal to 22. The range here is 22. Okay. Range is 22. So even with two negative numbers, I got a positive value for range, right? So the range can be negative? No. Range cannot be negative. What about mean, median, and mode? Can these be negative? Well, again, what if I was taking temperatures in Antarctica? We're going to have a negative value for average, right? So it's cold there. The middle value could also be a negative temperature. That's okay. Still, it's cold there. And if you were taking temperatures and like your highs were like -8, like that could be, right, the mode. It's like the most common observation happens to be a negative number. You could also look at net worth. In high school, hopefully your net worth is 0 or positive. But for folks, take out a car loan, right? The asset minus your liability, car, what it's worth, and what you have to pay on it. Like as soon as you drive it off the lot, it's now worth less, so you owe more on it than it's worth. And if you have a mortgage and you're not underwater, you know, asset minus your mortgage, your house minus your mortgage value, it's going to be a negative number. You have student debt, it's going to be a negative. Your net worth is going to be a negative. Doesn't mean that you're not worth anything. It just means like take all the stuff you own minus all the stuff you owe. That could be less than 0. Okay. For adults, sadly, it is. So our mean, median, and mode here could be smaller numbers, negative numbers, depending on the variable we're picking. Okay? So yeah, mean, median, mode, these could all be negative numbers, positive numbers. There's no restrictions. So answers for mean, median, and mode, you see A, any real number, that's what you're picking, each and every one. Okay? So be a little bit careful like that. I like to ask questions that, what kind of number can these things be? And that's okay. So what can be 0? Sure it can. Look at, again, go to temperatures, maybe not in Antarctica, maybe Toronto, right? It's like 0. It's an average temperature in the winter month. So yeah, it can be 0. It's okay. It's a number. So realize that's what kinds of numbers that these things could be is, yeah, that's one of the questions I can ask. So let's do a couple of examples. Yeah, that's it. I don't know if it's homework. I used to do homework walkthroughs, and I don't all that useful for you. Assume that yes, they are, but I also don't want to spoil new fun learning doing your. So this is 3.2. This is 5. It says here's some housing prices, right? And they would like to know, what is the population standard deviation for 2012? Around the 2 decimal places. So mostly what I'm doing this for is like, just to give a little more reminder, right? How to do this in your kind of stat. Well, actually, we're going to hit stat. I'm going to hit clear list. So I'm going to clear list 1. So I'm going to clear list 1. And I did some stuff that I also want to clear list 2. Okay? You don't have to. It's only going to deal with list 1 and list 2. But I just wanted to start with a blank screen. So find the population standard deviation for 2012. They have a part 1 and a part 2. You want to bet they're going to ask us to find the population standard deviation for 2013. I would bet that they will. So let's go and hit stat. Now I'm going to use my keyboard to do this. It's going to go a little bit faster, but I just don't need to get these numbers in. So it's 193. 29, 208, 208, 26, 2, 74, 3, 137, 3, 7, 359, 448. You don't need to point out. 265.4, 131, 311.6. Let's go over here and I'll say 197, 197.7, 69, 246.5, 216.7. Practice my 10 key things. This was pretty good. Three, 2.6, 141.8, and 348.7. As a matter of fact, we took stats the 90s. They would give us the data sets. And then, the problems were big enough. They're like, hey, you could get them off of your 3.5 floppy disk. Or type them in. And my little group, study group, was usually like to type them in because before I went to grad school, I was a data entry group. So let's go ahead and check this. So 193, 229, 208, 173. 250, is that 250? 359, 48, 65, 130, there, 131.8, 12. You should do your best to like double check. These in. Okay. Again, if you want to work together, Discord. Okay, it's good to work. That way, when you get to this spot, it's like, hey, did you get the same average I did? So, okay, what do we want to do? Find the population standard deviation. So we're going to go hit stat, calc, okay, one variable statistics. We're always going to pick that. This, no, for now. Okay, I just want to do it on list 1. Okay. And our standard deviation here, it's population. So they went to the sigma x thing right here. So 106 point, how many? Yeah, 2 decimals. 106.12 is 4, does not round up, it's down, so 106.2. 6.2. Okay. And then find a standard deviation in 2013. Go figure. So what we're going to do is we're going to go stat, we're going to go calc, We'll do one variable statistics. Here's where it's going to matter. Second list, right? So second function 2 for L2. That population standard deviation was 139.0. This 7 is going to make this 8 turn into 1. So 139.0. 39. Great. Let me show you the other thing that they're going to do. See this button, send to Excel? Use this to help you check. Don't do the problems this way, because when you're going to do a quiz, like, you're not going to have this button. So we know this is our year. And then all we're going to do is we're going to insert a formula. I would like to do insert a formula. Population, standard deviation. I haven't done this yet, so I don't know. Calculate standard deviation based on an entire population. That's the one we want. Okay. It's going to say what data would you like? So, no, I don't want this. I don't want a database one. I just want standard deviation. So let's see if that works. So plus standard deviation. Oh, look at that. Standard deviation P. Right. Dot P. And then that's DEV dot P. Then we're going to go ahead and have parentheses. Scroll all of that. That don't get to 2012. That's not part of the data set. That's just the year it happened. Where they come there. The mix adjacent cells. Well, yeah, I know. So, see, I don't have an error. So we hit Control C, Control V, copy and paste it. And what do you know? We got our 106.12 and 39.09. So this is a very, very fast way to do this. You don't have to do it this way. Actually, I prefer that you. Okay, but we're not going to police it. But that's what we do. All right. 6, 7, 7. Okay. 6 is pretty much where we're going to end. So let me go back to 4 and tab. So number of active breweries, samples of states located east and west of the Mississippi River. Compare sample standard deviation. That's what we have. So calculator and stat. And I'm going to go ahead and clear my lists because I don't need what was in list 1 or list 2. Here's the column. Cleared them. Like the stats, edit. Okay. What do you want to bet that part 2 says this is east, part 2 will say west, right? So we're going to do 52, 13, 8, 23, 30, 16, 15, 76. Wow, New York. 46 and 14. Right? We'll go over here and we'll just type in for California. Okay. Yeah, I guess technically Louisiana is west. I don't. You don't think of Louisiana being west. California 305. California also has a huge population. So it'd be interesting to see like a per capita. How many breweries per capita has in each of these states? Central Texas and Utah. Wow, Utah, go figure. I didn't think there'd be any breweries in Utah. So what we're going to do, stat, okay, edit, calc, And with variable statistics, what did they want? East of the Mississippi, so list one, enter, sample standard deviation, how many decimal places they were? One decimal place. So 20.45, this 5 makes this 4 into a 5. So we're going to say 20.5. Check. Right. And then what are you what are you gonna give? Like, wow, they asked for West. Calc, second function, list 2. Okay, so make sure we're getting the right thing. Sample standard deviation 107.8, and this 3 does not contribute anything, so 107.8. Okay, 107.8. So let's look at 6. There's a little put off. What we have to do here is we have to get the midpoint of each one. So what we're going to do, I'll show you how to do this in your calculator too. We're not doing this like by yourself by hand. That would be even worse than a regular standard deviation, to get a group standard deviation. I appreciate that they still teach this, but honestly, this is a 20th century problem. I don't care about this anymore. So we go from 0 to 0. Well, I say this, we don't care about this technique anymore, so we have better. Looks like a perfectly good way to make a histogram. We want to know the variance and the standard deviation. Following table presents the time taken to review articles that were submitted to publication. In a journal, the articles, one with 6 months. The articles took longer than 6 months to review. Those were omitted. Okay. Consider the data to be a population. That's what I was looking for. It's population. Now, we need the midpoint. We're just going to assume that every one of these articles took the middle time. Okay? The way you get the midpoint, 0 plus, so 0 plus 1, 2. It's half a month. So the midpoint here is 1 plus 2.0 divided by 2. So 1 plus 2, that's 3 halves, that's 1 half months. Okay, 2 to 3. 2 plus 3 over 2, that was 2.5. 3 to 4. It's 3.5. 5 here. And we have 4. Once. I think what we're going to do is we're just going to assume that could have been a 6. So we're just going to say this is 5. So it's 4.5. So that's the value we're going to use for these things. Articles. So we need to get the mean stuff. So what we're going to do is we're going to say, well, we've got 40 things that took half a month. So we have 5, 40 plus 1, 19 plus 15 times 2.5. System, right? So if you just follow along. By the way, if you're already swamped, you're like, I'm out. It's okay. We're going to do it in the calculator just a little bit. Tend not to like to give these problems anyway, because it's additional levels. All I'm doing is I'm multiplying by the number of times it happened. Right? So it happened in this case, right? It happened 15 times. That took 2.5 months to read. Here we're going to have 3.5. How many times did this happen? This will be 20. Okay, so 3.20. 4.5, 12. Plus 5.5 at 1. How many total things were there? It's my end. Using a capital N because of population, right? So this was, so this was 40, it's 19, it's 15, it's 20, it's 12, it's 11. That's where these numbers came from. That's my population size. So do it by hand. Take 3 plus 19, it's 15. So 15 here. It's 20 plus 12 plus 11. Okay. Total of 117 articles. Did they tell us that? No, they didn't. Sometimes they do in the description. They say 117 articles. Here's the breakdown. So we have to calculate this. This is how we're going to do our average, right? Remember, this guy's name is mu. This is our population. Since they said they wanted to be treated as a population average. Okay, so that's going to be this here. So it's going to be 0.5 times 40 plus 1.5 times 19. It's 2.5 times 15 plus 3.5 times 20. It's 4.5 times 12. It's 5.5 times. See if I can get it here. 4.5 times 12 is 5.5 times. Increase this divided by, okay, divided by 17. That's going to be my average. So let's go ahead and set that equal. So let's see here. We have 0.5 times 40 plus 1 15 plus 2.5 plus 20 plus 3. I just did 2.5 times 15, sorry. 2 plus 2.5 20 plus 4.5 12 plus 5. So it's 270 divided by 17. One, 2.2. All right, now that is my average. This was mu. So what we're going to do is we're going to subtract each of these pieces and mu. Okay, continue on. If we had to do this by hand, this is what we would do. Do not want you to do this by hand. That's a little taste of what we have to do. What you can do on your calculator. See what we have. Lists. Okay, we have two things. Let's go ahead and get lists. So stat, clear the lists. Sure. We're going to clear lists and lists too. Now what we're going to do is we're going to enter these in the calculator. Enter in, okay, the value. So we actually had to go through that value and the number of times that occurs. So we're going to go ahead and say list. So we're going to have 0.5, 1 point, 1, 2 point, 3.5, 5, and 5 point. Here, how many times did this happen? It happened 40 times. 19 times 15 times, 20 times, 12 times. So we're going to go into stats. Oops, stats. Calc. We're still going to do one variable statistics, right? Even though I filled out 2 columns, we're going to do one variable statistics. What I'm going to do is I'm going to tell it that, well, I'd like you to do stats on list 1, but I'd like you to use list 2 as my frequency. It should. Yep, should. 284 is a little bit better than this than 283. Okay, it tells you a little bit what's going on. 2.3112, that's my average. So standard deviation here, and it's a population. So this is a standard deviation. It's 1.7. So this is 171. What I'd like to do with my variance, okay? There, shoot. I'm afraid to use the 2 decimal places only. I think it's going to give me, sorry. That's how I get the variance. 2.92. 2. So we'll go ahead and check. Tell me this was wrong. Oh, no, it didn't. Close enough. But that's how you do those. I'm not a big fan of asking you this stuff as it is. So if you're worried, like, you're going to make us do this, like, no. The previous 5 problems is plenty. That's perfect. I will cover chapters, questions 7, 8, 10 in the next video, which will not be up until next week. But that's the second part through 2. I'm going to kind of combine some of that with 3. So there we go on how to calculate standard deviations and some other additional questions I might ask you. But that should do it for us. Okay. So I will see you next week as far as what's for data 3.2 and 3. So let's go ahead. Stop recording. Next week.